Since this is the first one for APM on this new channel, today we're really gonna do an introduction to application performance monitoring. I'll be presenting today. My manager Avi is actually on the Q&A section, so if you have questions, just post them. Application performance monitoring, really it's about application observability, where we're using a distributed tracing service to help you achieve the best application experience possible and improve DevOps efficiency. The application performance monitoring is part of a suite of services that is combined and called Observability Management services. These all live on the OCI infrastructure, so we're building them on top of the OCI infrastructure. We can receive many type of signals or events, as you call them, like metrics, events, logs, traces, SQLs, and each O&M service will then pick up these different telemetry types to provide reporting, insights, and analysis on top of that received data. It doesn't mean that your application actually needs to be on OCI infrastructure. It could be on-premise, could be on a different cloud like AWS or Microsoft, and also obviously the Oracle Cloud. We have agents that will create the telemetry data, and that gets sent up to the APM data pipeline, and we'll process it and provide you with the required reporting and insights as we see fit. So when you're talking about application performance monitoring, the key capabilities here really are tracing and profiling, real user monitoring, availability monitoring, application security, and analytics. And during this brief PowerPoint, I'll try to go through all these different sections and give you some insights, and then we'll end up with a couple of demos, and hopefully at the end, some interactive Q&A. Feel free to ask questions. So first things first, tracing and profiling. For me to kind of explain what tracing is, and many of you might be already aware and fully available on what it is, but for people that aren't, let me try to explain. If you look at something that is done by, let's say, a user of an application, clicks a page or opens a page, that normally ends up being a request to a web application server that then transfers that request to an application server. And that makes calls into multiple microservices at the end, ending up with some database updates or something else, right? What we do is we provide agents both on the browser side as well as the backend side that keep track of activity. So each component here receives a request or a job to do. And what it will keep track of is, okay, I've got this job. It took me so long to complete it. There were no errors, or there were errors. And if there were errors, I can give you some relevant log events, for instance, or metrics that go along with it. And each and every component here sends off that small report of that job, and we call those spans. These all get sent into APM individually, but if the first that creates that request doesn't see that there was a what we call trace ID, it will generate a trace ID. Every component that follows suit afterwards will see that as a metadata on the request, and it will keep that information while it sends off its own job report. So each and every span has two things. It has a span ID, which is basically the ID for the job that it's done, and it will have the trace ID. And for us, when we receive that information, we process all these different spans. Besides we're keeping them as individual information pieces, we also process them into traces, so that you know that requesting this particular page actually made calls into 3 different microservices, and on its turn, they had this path in the application logic, right? So a single trace, let's see it as a page update or a new page being loaded, might have many of these different things spans, jobs that are done somewhere in a part of your application that we need to keep track of. And by keeping that trace ID, we can see, okay, that page took so long because the culprit actually was this particular database update that was not performing. So that's, in a nutshell, what tracing is all about. Now, we build a service that's designed to accept high span volume. We really want to encourage people to accept and store all 100% of the traces, because you need to know where applications were acting up, which parts of your application are not performing, and you need to know why. We keep this data for a long period of time, by default a year, so that you can do comparisons between different releases, different time periods, see if there's degradation going on or improvements. We keep it in a data store in an ADW, and we've provided a intuitive query language on top of it, which we call trace query language. That is near SQL to ask questions, filter, and provide visualizations as you're seeing here. Out of the box, we've got a couple of dimensions that are always present on each and every job report that comes in, but you can extend it by creating customizable dimensions, and if you're missing metrics, you can add metrics to it. We're open to telemetry compliant. With that, I mean that if we don't have an agent for some specific technology, there will be an agent out there in the open source community that will provide the same information in a standardized way in the OpenTelemetry format. We can consume that data, so it doesn't really matter whether you're using our agents or the open source agents. We're completely compliant to receiving both and processing both. On our agents, we also offer something like deep dive diagnostics, where you can do more things like profiling. If a job takes long, you want to know, okay, what's actually going on under the hood, figuring out which particular activations or which particular jobs took long. Our agents are highly configurable, so that you have control over the type of data you're collecting. You can mask data, you can sample data, you can add metrics, dimensions, and many things more. The second topic here is about real user monitoring. So besides getting things into a tracing status, from a browser perspective, you want to make sure that you track all user interaction. So you want to track a session, which is someone logging onto an application. Which pages did they open? Which navigations did they do? Which AJAX calls were called because of that navigation or that page load? And we measure both the load times, so how long it took for the browser to receive that information and how long it took to basically present it back to the user, as well as network times. So if there are DNS issues or SSL handshake issues, you can see where that problem actually occurred. Is it because your application is not performing, or is it because the connection to your application location is proven at that time to be complex? We also track JavaScript errors. So when something happens, maybe you're not even downloading a new AJAX call or something else, but you're interacting with the UI. Normally that's completely JavaScript, right? So we're tracking these errors. We allow you to upload the source files for minified JavaScripts so that your developers can actually see exactly in which line of code a problem occurred or why the UI is not functioning as you're intending it to be. We have a dedicated browser agent that you can deploy anywhere. It's just a piece of JavaScript that you can deploy in any application. And for our agents on Java and .NET, we actually have auto agent injection, so you don't have to deploy the JavaScript yourself. We can make sure that the APM agent takes care of that. Again, OpenTelemetry compliant, and you can customize it and extend it as much as you want. Next topic, availability monitoring, which is an important one. Any application monitoring or any application solution should have something where you can see whether the application is still available. And you can't get that just from looking at the release monitoring or just looking at the spans that are created, because you need to check whether something is still behaving or accessible in the way that you intended it to. And you can do this through monitors. So you create monitors, either scripted browser or scripted REST, which means that you're creating a script that interacts with the application through a browser or through an API, where you're saying, okay, these are the steps, right? For a browser, for instance, I'm logging in, clicking on the home page, then clicking on opening a customer record and updating the customer record before you log out. You create that script and you provide that script to us. We execute it at a given interval that you define from locations that you define, and we'll tell you whether that script is successful or not, but we'll also tell you what the performance of that script is at the time. So since you're doing the same thing, let's say every 5 minutes on a day-to-day basis, you can really see whether your application is performing the same way it did yesterday as it did today, right? We provide, as I said, browser scripted monitors, REST scripted monitors, but we also provide an option to check the network connection, so do a network trace, provide tests that would check for the DNS, whether DNS is still available, whether your certificate is being handled by the right authority server, those kind of tests. And we just recently added the FTP secure file transport test as well as the SQL. And the last one, the SQL one, is pretty important, because if you have a database that runs on a different cloud that's connected to your application, can I access that database? That's the first thing. But also, when I do the same SQL execution over and over, is it behaving in the same way? Does it perform in the same way? So we allow you to create these SQL tests and really test whether you can access your database in the way that you would like it to do, to prevent that you have issues in your application because of that database connection. While we execute those tests, we collect and retrieve what we call HAR files, HTTP archive files. Basically, it's like going to your developer tools in a browser console and seeing these network statistics about whatever is being loaded in your UI, right? We store that information. We store the network traces so that you see which hops were taken from the location where you execute the test towards the location where you have the application hosted. Is there any problem? Is there any link delay? Are there any hops that might be out of order for a particular period of time, so that you can separate issues on a network from issues with your application? Any of these tests can be run from either public vantage points, and we have all the OCI data centers where you can run those tests from, but we also have roughly about 20 external locations which run on a different cloud, so not an Oracle cloud, where you can run these tests from to make sure that even if you're having a connection from outside of OCI into OCI, whether that still performs and is doing what it's supposed to. Then when you run your application on-premise and it's not something that you can test from an external location, public location, because of security, secured networks, we allow you to apply on-premise vantage points, either on OCI, which we call dedicated vantage points, or you can deploy them as a Docker image inside of your own corporate network or corporate office somewhere. You run that Docker container and can run the same tests as you can on public vantage points. When we do these executions, obviously we can collect all this information, but if your application at the same time is also set up to have APM agents, we can go to the traces of that particular execution and see it in the context of an individual test run. I'll go into that in a small demo. You can put in custom metrics. So if you have an entire script that says, okay, log in, do this, and then log out, you might not want to be interested in the login and log out part of the transaction, but just focus on what's actually being done in the application. So we allow you to put markers in the script so that you can kind of separate that timing from the overall execution. And we can do availability reporting based on these executions. And just a small sidestep, I think everybody has this need to do some kind of a service level agreement, right? Whether it's internal or, as I'm showing here, on the Oracle Cloud, we have defined thresholds that we need to meet to make sure that you as a customer can access Oracle services. And in our case, we stipulated that that availability means that you and your users are available to log in and access the service that's provided. And if you cannot do that, then there are penalties, right? We have to give a discount to customers that at a particular point in time cannot access their application. The way to do that, or the easiest way to do that, is through availability or synthetic monitoring. It allows you to write a script that does exactly what your SLA is describing. Check if that's available at the time of the execution, and provide comprehensive availability metrics calculated over time. So it allows you to say, okay, for this period of time, I have a planned downtime. So ignore any issues that are there. You can also say, well, I'm running this from 5 locations, but if 3 of them succeed, it's still available. It's not an application problem. That's probably a connection problem to the application, right? So there are kind of bells and whistles to make sure that you can do the right calculations. And whether you use them in an official contract like the SLA for the Oracle services, or it's an unofficial internal doc, or you just want to provide some availability metrics to your management, it's useful to have these kind of data, a single point or a single metric that says, yes, usable, or no, it's not usable. So that's where synthetic really comes in. Besides doing the tracing and the real user monitoring and the availability monitoring, all these jobs that report spans, right? We can help doing application security in 2 ways. One is your application is being accessed from a location. You have the IP address. What we can do, or what we do out of the box, is check that IP address, whether it's something that's known to be like maybe it's a bot, maybe it's a bad actor, maybe it's something that is known to have is known to be a bad individual to try to do something with phishing or something like that, right? We are integrated with the threat intelligence service at OCI, so we know which IP addresses would be bad actors or could be like bots, so that you know how much of your volume of requests in your application actually is normal users versus something that's qualified as a malicious user or a bot user, right? So how many resources are you wasting or are you using to provide answers back that are not maybe your key business, which is serving to actual customers? The second benefit is, for all the jobs, if a microservice is run on a particular Java version, and there's a library in there that it has a known CVE, just by having the report which Java libraries were actually executed or which were called inside your microservices application, you can identify known vulnerabilities. You know exactly whether something that's published as a CVE is actually also present in your current application estate. So those are the 2 types of reports that we're offering through application security. Then moving on to analytics. So you've got all of this data, all of these jobs and traces coming in. How do you use them, right? So we store them in ADW, and we have, as I said, these trace query language on top of it, which is really like SQL. It allows you to do a lot of filtering, making sure that you have the right set of traces, the right set of spans that you want to look at, and then do analytics functions on them, like clustering or do statistical functions on top of the filtered data. You can provide visualizations. We have a couple of out of the box, like a table, geomap, topology views. But you can also use that same SQL to create widgets that you can share on dashboards and those kind of things. You can save those queries so that people that are not as knowledgeable on the query language can still use the UI by just clicking on something that you've defined as, hey, look at sessions, look at pages, whatever, right? So it makes it easier to share this across the organization. As I said, we're creating out-of-the-box dashboards, which are things that we created. We curated trace and metric data, and we have things for user monitoring, for synthetics, for services, app servers. But 9 out of 10, you might think, okay, this is a great view, but I want to add a view to it. So this is all customizable. You can just use the dashboard framework to add new widgets or new visualizations as you see fit. And by the way, these are not just limited to APM. All the O&M services provide these functionalities, and that means that one single dashboard could contain both APM information, but also stack monitoring information, logging analytics information, database management information. So you can really provide a view out of the box to your users without them really knowing what's behind the scenes to get the view that they need to do their day-to-day job. We also have functionality where we can prepare data. If you're asking a question on the unique users of your application over 3 months, you might have to go over millions and millions and millions of different, or even billions of different data points. Getting that result back might take a little longer than the UI wants to wait for it. So what we allow you to do is create a background query that runs at a scheduled interval. And the outcome of that query is actually stored separately in a table for you, so that if you build a dashboard or you want to create an external view on it, you just use that prepared data. And that means that you're going against a very small data set and present the data as needed for a particular time period. All the data that we have is available through our UI, through our APIs, which also means that if you have a data lake somewhere or using Oracle Analytics Cloud, for instance, you can use the same query language to nitpick basically what you need from the APM data store and use it at external sources for whatever type of reporting that you need to do. The third thing that I think is important in terms of analytics, we're getting all these signals, right, from browser, frontier, backtier, and they go into our data pipeline. Sometimes developers have not put the right terminology in the metadata, or they forgot to remove some of the information that you would consider PII, or they're saying some of the information is there that you might want to interpret, right? So, for instance, out of the box, we get the IP address, but where's that IP address located? If you have offices somewhere, they probably are on an internal IP subnet. You would know which location that would be, the office in Houston, the office in Seattle, but you would have to provide that data. And what we allow you to do in our processing is basically give us that additional data, whether it's geodata or the threads or even a mapping file where we're saying, I've got this customer ID, but I know that customer is actually like a golden customer or a silver customer. You can provide those mapping files, And during our processing, we will add that information to the signals that we're receiving, which means that you don't have to change your application. You don't have to ask your developers to change the application and change the metadata. You can change the metadata as it comes in. It also means that you can do additional things as it comes in, like bucketizing or do name corrections for values that come into the data pipeline. Once it's there, again, on the storage side, we have these background queries where you can curate data and prepare data sets in the way that you would like them to be used, so that you don't have to change your application, you don't have to change, or you don't have to pull data out and do a lot of data crunching. You just allow it to be done in APM and provide with the reports that you really need for your business purposes. All right, with that, I've gone through all the, let's say, areas of APM. I'd like to go to 2 small demos, and then we'll open it up to QA. First demo I want to kind of talk about is the synthetic side of things. So I'm looking at a dashboard here about monitors. So these scripted tests that I was discussing before, they're running. I've got an availability metric here. Our dashboards have the ability to implement filters so that I would be able to say, okay, this is a mobile type of test, or it's a web test, or I would filter down on particular test in the UI. I now have a view on all the executed monitors, but I'm seeing here LuxMine has a problem. So if I click here, the UI is updated and not every monitor is being shown, but just this single one. I can see that there's a particular failure happening on Japan East. So if I want to investigate that, I can just click on this one and get to a list of executions for this particular monitor. I'm seeing here there's one failure, same as I was seeing in a dashboard. First, let's check if that has something to do with network connectivity. So if I select it and go to actions, and then to the network trace, basically, I can see how it came from the external vantage point to our demo app. But by exploring more of these hubs, I can see, hey, there's actually some probably a link delay that's happening on these particular components. I can select one of them and see, hey, okay, this connection takes longer than 100 milliseconds, which obviously is not something that you would like to see. Whether it's really the culprit of this issue remains to be seen, but it just allows you to see what the network path is into this test. Another view that you can do is view the heart. And with this, like I said, HTTP archive, right? It gives you what I would say a waterfall view of everything that happens because you executed this test. I can look at all the individual components. So it took 3.6 seconds to load. And then for each and every component within that page, it tells me exactly how long it took. And I can look at one of these things and say, oh, it took actually more than a second to receive this file. It's quite large, but still pretty slow. At each end of a step, we also allow you to capture screenshots so that you know what you're looking at in part of that execution. If I close this down, again, if I've set up my APM agents on the application side, I can also go to the trace details. So now I'm actually going into Trace Explorer, which stores all these spans and traces. And I've selected a particular monitor ID from a vantage point with a particular time frame. So this is the exact monitor that I was looking at that gave that error. And I can see now that there's an error on one of the pages. That probably caused the timeout. So it's a good way of doing something automated, scheduled, and then getting back into the details on this side. As I said, we have these out-of-the-box dashboards. One of them is our homepage, where we're just giving you an overview of everything that happens in the application, what's the topology of our application, where are users coming from, but also which traces are we capturing, right? And which are complete and erroneous and successful. But let's say that you've got a scenario where you need to find in these traces, and you've got a customer calling in saying, I've got a problem. Pages are not loading for me. It's very slow. How do you get to there, to that particular piece of information, right? So we have sessions. So something that organizes each and every set of traces and spans into a user session. I could sort them by response time so that I have the most slow users here. Let's say that this user calls into your support and says, I've got a problem. This thing just doesn't respond really well. By going to the traces, I can immediately see that the problem here is with one page, which is the Wine-Stockholm form, because that takes 41 seconds to complete. Clicking on that trace kind of explodes to me what happens on the back end, right? So the errors here, how bigger they are, the more time is being spent on this particular scenario. So I can see that it happens on a checkout service, and that checkout service eventually makes a database call, and that is taking 37 seconds. So from everything that's long, probably this is the culprit of what's going on here. I can use the topology view to do this, but I can also look at additional details by going to the same view, but then in a kind of a table view. I see the same checkout service, and then where that JDBC call is being made, out of the 41 seconds that we took, 37 are actually happening on the JDBC call. Now I can go to the exact details of that individual job, right? So this is a microservice making a call into the database, and it's waiting for 37 seconds to come back. So what is happening there? And now I look at all the data that we're collecting for this particular individual job. It tells me where it's running, on what type of app server it's running. It tells me what the type of call is. In this case, because the JDBC call, I can actually see the connection to which database it's making that connection, but I can also see the SQL ID, for instance. And that opens up new opportunities, because if I go back to the top, you see here, like there's a bunch of links here, which we generate, which are integrations to the other parts of the observability and management services. For instance, PerfHub, I can go in, look for that same SQL ID that I was seeing on the individual span, and see which activity was done on the database, looking at hash analysis, and see if there was an activity on the database which was unusual or bad. Now, I'm not a DB expert, so I won't go into this in detail, but just to show you that that integration is there. But this SQL, though, might be something that you want to investigate and see, hey, is that happening more often? Because it's kind of weird that this is happening. What I can do is then go to the SQL short link and see how many times that occurred. And the same SQL shows up as actually the highest count that's being done. But my invocation actually took almost 40 seconds, right? And in this case, the average is 1.4. So is that common? Are there few outliers? So you might want to kind of see a histogram of the division of how many times it's fast versus how many times it's slow, right? So if I click on this, I can see immediately, like, there's executions where it almost doesn't take any time, and there are executions where it takes a long time. So getting to that histogram view, I'm using what we call saved queries. I can open this up, look for something in like a histogram, and open that SQL histogram. And when I do, I can actually see that the bulk of these executions are going very well. Like within 1 millisecond to max like 2 seconds at least. But there's still like hundreds of executions that are slow and very slow. So it's something that you would need to investigate with your DBA to figure out, okay, what's going on and why is this happening? To me, that's the demos that I wanted to do. I'm hoping that there are a couple of questions on Q&A. Avi, I think you've been handling those. Maybe you're on mute.
We have one question. But go ahead, Avi, sorry.
No, go ahead, Catherine. Yeah.
The question is, Oracle database has ADDM, Automatic Database Diagnostic Monitor. It's used to identify bottlenecks in management. Is this component integrated in observability and management solution? And are you exposing that right now? Are there any kind of advisors of ADDM for the full stack?
We're showing you, so what I did was the integration from APM to database management, right? So you can go from one to the other. If we have from the metadata in the application saying, I called into this database, I use this SQL, I use this connection, then we can go to Perforop ADDM and basically look up what was going on at the time from a database perspective. So that's the integration that I've shown. Avi, feel free to add if you need.
Yeah, the ADDM feature itself is actually implemented as part of DB management. And so the drill down comes from APM in context, but the implementation of the same ADDM that you had earlier, it will be in the DB management, which is one of the other O&M services that you can see in, it's part of the platform. I assume we will have a session on that in one of the future weeks. There's a couple other questions you can see them on the Slack, Catherine. I think first one, maybe Jürgen, you want to answer. How is it? How do we pay? There was a question about charging. How do we charge for APM?
So basically, we charge by the volume of spans that you send to APM. One unit is 100,000 spans an hour, which for a moderate application is sufficient. And then from there, it kind of goes up. That's the span part of it. And for synthetics, there's separate licensing, which for every monitor execution that you do, we do 10 executions an hour as of one single unit, and you pay for that. So there's just two components. One is how many data you provide or you upload to APM as spans. And the second one is how many synthetic executions you do. And the good thing about it is like it's per hour, right? So if you have an application that's like I don't know, an enterprise application, you'll probably have like 8 to 10 hours a day where you do 90% of your traffic. For the other hours, you will still have your monitoring, but you're not charged the same because at that time nobody's accessing the application or less people are accessing the application. So your license also is limited. It really we listen to the amount of volume that we see every hour, and that's what you charge with.
Can you talk a little bit about APM and if it can be deployed on AWS?
Sure. I mean, for us, APM is deployed on OCI, right? So the service itself lives in OCI, but the agents, whether it's a browser agent or it's a server agent, you deploy anywhere, whether you have an application completely on-premise or it's in AWS or it's on Azure. We don't really care. It's a piece of code that runs inside your application service, not related to any of the platforms. So we don't really care where it runs. It just sends off these spans to the APM endpoint, and we authenticate through keys and authorization, and then we push that data into APM, and the data store lives in OCI, and the UI and everything else lives in OCI, but where you collect the signals from can be anywhere.
So does that mean if you have an app in AWS that might connect to a database in OCI, can you use APM to test that connection?
Exactly. Yes. You can use it to, well, using the SQL synthetic monitor, right? You can test it, but if you instrument the application, then you would see every span coming in from the application that's hosted on AWS, but still see how the JDBC calls would be that are hosted on AWS on Oracle, for instance, or vice versa.
Yeah, actually, it makes sense to add here. You mentioned at the beginning the synthetic monitoring. So there's since there are cases where the application runs in one data center, in one cloud with one cloud vendor in database ADW or large databases that are stored that are used in Oracle Cloud. And when the application this is the kind of the main database, you obviously this is an ongoing thing, but there's cases where you load every so often to get some analytics data and so on, and keeping the connection alive is sometimes challenging. And Jürgen mentioned that the SQL monitoring, that's exactly what it does. So you can use our on-premise vantage point. It's called on-premise because you can install it anywhere, but it's actually, you will install it in where your application is on the internal network on AWS, for example, in this case, where your application is running, and make it configure it to use the same network that is used by the application to connect to the database, regardless what the database is, whether it is on AWS or it's on the case that the more complex case where it's on OCI. And test this every 5 minutes, run a SQL to make sure that the database is actually available. So when the application needs it, it's there. Similarly, it works if you have your application on premise, or your application is OCI and your application is on premise. You need to ping the database, and you want to make sure that it's there before the application fails to run.
Yeah, and check performance, right? If you do the same SQL every minute, you expect somewhat of the same performance. And if 9 out of 10, if there's a connection issue, you'll see, even if it's not, if you haven't lost your connection, right? But there might be intermittent issues, you'll see that your performance time goes up. So it's a really good way of checking these things.
Hey, Jürgen, there was another question about real user monitoring for, actually the question was specifically about Siebel, if it's available, but I think maybe
Yes.
it would be good to answer regarding all of Oracle apps.
Yeah, so we have kind of a little bit of a different configuration settings where, since we know the Oracle apps, right, like Siebel, EBS, JDE, whatever, we already pre-configured the browser agent so that it knows the right terminology, right? In Siebel, you're talking about views and applets and those kind of things. Instead of on a normal application, you would talk about pages or page navigations. So we've already pre-configured our browser agent to do a bunch of those things, and amongst others, Siebel is one of them.
One more question is about MFA and synthetic monitoring.
Yeah, we support this through a the one-time session, one-time token, session token. So it's not through a validation with a mobile application, but when you can use a token, then we can use the token to actually call into the service, get the token, and log in. So that way the MFA is supported.
Yeah, actually, we use it in our own case. When I log into OCI, I have to do authentication through my mobile, Oracle single sign-on for our own employees. But for monitoring it, there's the administrator provide configuration that allows you, there's a special solution for that allows monitoring for multi-factor authentication. That's through that key that Jürgen was talking about. So it's a well-known capabilities or features that are available for applications that need to be monitored that are protected by multi-factor authentication. And the required side of our side of it, the synthetic monitoring provide the capabilities to actually do this.
There's also a question about how you can protect PI data of the monitored end users. So does it capture the name of the end users, and what does it do with that?
By default, no. Customers can say that they want it. They can say that they want to obfuscate it. And then, so there's two ways, right? On the browser agent, you tell the browser agent what you want to collect. By default, we won't collect usernames, but it's possible. And then on the ingest side, as I said, with spend enrichment, you can say, okay, I'm getting this value, but for instance, create a key out of it, or obfuscate the first 5 characters of something, right?
Mm-hmm.
So that you don't have an issue with PII data. So I do it at the source, so before you send the data over. But even when you, I don't know, forgot it, or it's hard to do at the source side, then even on the processing side, we have capabilities to ensure that you're not tracking items that you are not supposed to do.
How long is the data retained?
Our data is retained for 13 months.
13.
Yep.
Okay.
And by the way, back to the synthetic test, I just thought about it when Avi was mentioning multi-factor. If you use passwords, right, to access an application, we actually have integration into the security vault of OCI, so that if you're using passwords in your scripts, they're not actually stored in the scripts. They go into the security vault, and APM through a policy get access to ask the security vault for the password. It's never maintained in APM. It's never stored anywhere. It's literally taken from the security vault. And it also, added benefit there is if you ever, well, if you rotate your passwords, you don't have to update your scripts. It just, you rotate whatever information is in the security vault, and you actually update all your scripts doing that. So it's a very easy feature. And we'll share these links out. There's a ton of YouTube videos on how to do things, tutorials. You can actually go to, Oracle Learning to get certified. We have blogs, we publish blogs about various topics around APM very regularly. And we have a couple of live labs where you can hit the ground running. You can kind of get familiar with how things work without kind of implementing on your application. And the final APM for free, right? It's limited to the amount of data that you can send to it, but anyone can set up an APM domain and try it out, instrument an application, and see what the data looks like if you're collecting it for your application without charge, part of the always free tier.
So if there are no more questions, I can conclude this session. Thank you, Jürgen.